The last method for solving quadratic equations is the quadratic formula. Now, the quadratic formula should be your last resort. This is what to do when all else fails, because the quadratic formula is always going to work, but it is the messiest thing. Now, the quadratic formula is this messy formula that you see right here in the middle of the page. It is a formula that you need to memorize, okay? Now, there's a lot of songs and ways that you can memorize it out there on the internet. Find something that works for you, but you do have to memorize the quadratic formula. So, this is all based on the values of a, b, and c from the standard form of a quadratic equation, just like we've seen lots of times. So, ax squared plus bx plus c equals 0. So, again, what's really important here, just like when we factor, is that the equation has to be equal to 0 when you start, okay? So the quadratic formula is this. The opposite of b, now remember, a negative in front of a variable doesn't mean that the number is going to be negative. It means it's going to be the opposite. Because if b is negative already, negative of a negative is going to turn it positive. So that's why I like to think of it as the opposite rather than a negative. So opposite of b plus or minus the square root of b squared minus 4 times ac all over 2 times a. And this formula was actually derived using completing the square. If you were to use the complete the square method on this general ax squared plus bx plus c, the solution you get is that mess over there on the side. And I'll spare you the proof, but that is how you would prove that this formula exists. Okay, so this is just a bunch of computation, and you want to be really careful and go really slow and make sure that you're not trying to do too much work in your head, because that's when you lose track of what you have. So I'll leave the formula there at the top so we can kind of follow along. So let's look at example 1. Again, first step is make sure that it is equal to 0. Number 1 is, so we're all set. So we need to start by figuring out our values of a, b, and c. So it's a 1x squared, that means a is equal to 1. It's a negative 6x, so b is equal to negative 6. And the constant is a positive 4, so c is equal to 4. So the formula is x equals the opposite of b. b is negative 6, so that means it's going to be positive 6, plus or minus the square root of b squared. Always substitute in parentheses, guys. The negative really matters here. Remember, we've talked about this lots of times. If you put negative 6 squared in your calculator versus negative 6 squared in your calculator, those are two different questions, and they will have two different answers. This is not what you want, because that is going to give you negative 6. That says negative 1 times 6 squared, not negative 6 squared. So use parentheses. Make good habits. So b squared minus 4, that's always going to be a 4. That's part of the formula. Times a, which is 1, times c, which is 4. And that's all underneath the square root. And then all of that is on top of the fraction divided by 2 times a, which is 1. Okay, so that's everything plugged in. Now we just need to do some simplifying down. So 6 plus or minus the square root of negative 6 squared is 36, minus 4 times 1 times 4, which is 16, all over 2 times 1, which is 2. And that's 6 plus or minus the square root of 20 over 2. So now we need to check, can we simplify the square root of 20? And there is a perfect square that goes into 20. That's 4 times 5. And the square root 4 is the perfect square. So this is 6 plus or minus 2 root 5 over 2. And now here's what's really important. If you're going to simplify this fraction, you always have to simplify in a triangle. So we always need to look here, here, and here. If you cannot divide all 3, then you have to leave it alone. But I can divide all 3 of those numbers by 2. So this becomes 3 plus or minus 1 root 5 all over 1, and I don't need to write the over 1. So this would be our final answer. Now again, if I look at that original problem, it's not factorable. I can't use square roots. I could have used completing the square on this one, but we're practicing quadratic formula, so that's why we used what we used. Okay? Every single one of these is exactly the same. It is plug and chug. Plug it into the formula and crunch it down. Let's look at number 2. Number 2 is not set up the way we need it to be. We need it to be equal to 0. So we need to start by subtracting 12x. That's going to be a like term with the 8x. And then we also need to add 4. There are no like terms over here with the plus 4, so it's just going to tag on. So we get 25x squared minus 20x plus 4 equals 0. So these are some big numbers over here now. So let's see what we've got. A is equal to 25, B is equal to negative 20, and C is equal to 4. Okie dokie. So let's plug it in. We have, pick a different color. X is equal to the opposite of B. So B is negative 20. That means it's now positive 20. Plus or minus the square root of B, negative 20, squared, minus 4, it's always minus 4, times A, 25, times C, 4. That's all under the square root. And all of that is over 2 times A, which is 25. Now we just crunch it down. So we have 20 plus or minus the square root of 400 minus 400 all over 50. And this one is interesting because 400 minus 400 is 0, which means the square root of 0 is 0. This whole thing makes 0. 20 plus or minus 0, it doesn't matter if you add 0 or subtract 0. This one's only going to have one solution. 20 over 50, which is just 2/5. Only one answer this time instead of 2. And no square roots in that answer. Now, it is possible that you might get imaginary roots. It is possible that you get no square roots where you need to add and then subtract because they're all like terms. So just pay attention to the kind of solutions that you might get. So pause your video and I want you to try number 3 and number 4. Use the formula, get it equal to 0, set it up, plug in your numbers, and come back here and get the answers in 3 seconds after you've paused and tried yourself. Alrighty, here are the answers that you should get. Now, take a moment to pause and check through your math if you need to. I want to explain a couple of things about the final answers here. On number 3, we check the triangle to simplify. We get 6i because it's the square root of negative 36. Now, when we check the triangle to simplify, we can divide all of those by negative 2. But why do I not have plus or minus negative 3i? Because what this says, if I have plus or minus 6i, that means once with a positive 6i, once with a minus 6i. If I divide that by negative 2, then that's going to be once with a positive 3i and once with a negative 3i. So it still has both one positive and one negative. It doesn't matter what order they're in. So it still includes a positive and a negative, even though I divided by negative 2. So that's why with the plus or minus in front, it's still got a positive and a negative, even though I divided by negative 2. So I don't need to write plus or minus negative 3i because the negative is already included in there. And then on number 4, again, when we get to the end, these are all like terms, okay? They're all whole number integer values. So we need to combine them down. There's no square roots, there's no i's. If they are numbers that you can add and subtract in your calculator, you should do that. And so that's how we get x equals 0 and x equals negative 11/4. Okay, so that's how we use the quadratic formula. And so that's what you're going to practice. And that's where we'll stop for now.